Hey, I'm Dr. Nate Bosch, Director of the Lilly Center for Lakes and Streams, and today we're talking about nutrient cycling, and we're in a great spot to talk about that because we're right here next to one of our live stream sensors. We've got 14 of them throughout Kosciuszko County here in northern Indiana, and they're looking at water that's moving into and out of some of our lakes. So the stream sensors start with the sensor itself, which sits down in the bottom of the stream channel. I've got one out here with me because of the ice down there right now. And it uses Doppler technology in order to look at how particles are moving past that stream sensor. And from that, the stream sensor can pick up on how much water is moving through, what the flow rate is. It can pick up on water velocity if it's moving through. It can also measure the depth of the water in that particular stream at that spot. It also looks at water temperature, air temperature, barometric pressure. All of that data comes here into our data logger box. This box has got storage for all of the data. It's also got the communications that gets that data eventually to our website. So anybody can go on our website and see day or night, any time of the year, exactly what all of this data is showing around our particular county. The solar panel here is what powers the data logger center, and there's a battery in there as well to help when you have nighttime and several cloudy days in a row, like we often have here in northern Indiana in the winter months especially. Let's move on over towards the stream and talk a little bit more about the nutrient cycle from that vantage point. All right, now we're down here by the stream channel, and we're talking about nutrients and how nutrients relate to our stream sensors. So the reason we have our stream sensors above and below several of our lakes here across our county is to be able to develop nutrient budgets. So we want to know how much nutrients, nitrogen, phosphorus primarily, is going into our lakes and how many nutrients are coming out of our lakes. It gives us a great sense of how healthy those lakes are. So when we have the stream sensor, it's measuring the amount of water that's moving through the stream channel at any particular time. And so the units would be something like liters per second. How many liters of water are moving through this stream channel every second of the day? Now we need to go take a water sample in the stream alongside that stream sensor and use that water sample to analyze the amount of phosphorus or nitrogen that's in that water. And that is going to give us a concentration of phosphorus or nitrogen. So phosphate, for example, is a common type of phosphorus that we would sample for. So we'll get a measurement of phosphate that would be milligrams of phosphate per liter of water. Now you can maybe start to see how the math is going to work, right? If we have milligrams per liter, and we're multiplying that by liters per second, the liters are going to cancel out and we're going to get milligrams per second. So we're going to get the mass of phosphorus that's moving through per unit time, such as seconds. So we can then scale that up over the course of an entire year, and we can figure out how many kilograms of phosphorus moves into a downstream lake per year. And we can only do that because we have the stream sensors that are constantly measuring water, which moves up and down throughout the day, and with snowmelt and rainfall and droughts and floods. And the concentration of the nutrients themselves are going to be a little bit more stable than that. And so we put the concentration of the nutrients along with the flow of the water, and we can then from that figure out exactly how much phosphorus, how much nitrogen in different forms is entering our downstream lake. And then when we look at the same data from the outflowing stream, we can see how much is leaving the lake, and that helps us develop a budget of nutrients for the lake itself, how much is going in versus how much is going out. Why do we care about nutrients? Well, nutrients make up the base of the food chain, and nutrients also continually cycle within our lakes. So the food chain, just to remind us, we have nutrients coming in. That's the base of our food chain. Those nutrients help feed the next layer, the next link of our food chain. That would be our plants. Things like phytoplankton, also known as the algae, or the aquatic macrophytes, also known as weeds in our lakes. Those plants then are going to feed the next layer, which is the zooplankton, the tiniest little animals that live in our lakes. That layer is going to feed our planktivorous fish, our smaller fish. That layer is going to feed our piscivorous fish, our fish that eat other fish, our larger fish in the lake. And as those different layers eat each other or die or decompose, or as we have waste products coming from some of those animals in the lake, it's going to bring nutrients back again to the plant layer that we have, and it's going to be recycled throughout the lake until it either gets buried in the bottom sediment of the lake or it moves out of the lake through that outflowing stream. Okay, so we've talked about why nutrients are important in our lake. We've talked also about how we can quantify the nutrients going into and out of our lakes. Let's talk about what some of the sources of those nutrients are. So we're here by a stream. This is called Kiefer Evans, is the stream name. It flows into Winona Lake, which is in Kosciuszko County in northern Indiana. This stream comes through lots of different sorts of land uses. It comes through just upstream of us here, there's a neighborhood, and there's some smaller ponds within that neighborhood that this stream flows through. So you have people's yards around there. You also have some golf courses upstream, and those would be other places where we have nutrient sources. We also have agricultural fields. So where are the actual nutrients themselves coming from these different land uses? Well, fertilizer is one. If you look at a bag of fertilizer, it's got 3 numbers on it: amount of nitrogen, amount of potassium, amount of phosphorus. And so those nutrients then, if we have too many nutrients on an agricultural field or someone's lawn or a golf course, and those plants there that are planted and growing, whether it's grass or a crop, if there's more nutrients there than those plants can absorb, the excess is going to run off with water, precipitation in the form of rain or maybe snowmelt. Those excess nutrients are going to come into a stream like this. So we can get fertilizer would be one source. Another source would be sediment. Maybe we've got over here along the stream, there's a little bit of an eroding area here along the stream bank there. And when you have that eroding area, it's going to allow sediment to come into the stream. And often phosphorus, not as much nitrogen, but phosphorus often will adsorb or connect to sediment particles. So wherever the sediment particle goes, that's where the phosphorus is going to go as well. So as sediments come into the stream channel and flow downstream, so too phosphorus, sort of a hitchhiker along with that sediment coming down. We can have sediment coming from an agricultural field. Maybe it's being tilled in the fall and we get a big rainfall that washes some of that sediment into one of our streams. That can be another source. We can have sediment from a construction site. Maybe there's not silt fencing around that construction site as there should be. And so we can get sediment moving nutrients into one of our water bodies in that way as well. So fertilizer, sediments. Another is animal waste. And so it could be wildlife in a more wild area, in a more urban environment. It could be pet waste. It could be people waste with septic tanks or wastewater treatment plants. Those are all going to be nutrient sources which move through streams and eventually end up in some of our lakes. So nutrients are a good thing. They make up the base of our food chain, as we talked about in our lakes and streams, but we can have too much of a good thing, and that's really what we're looking at here in Kosciuszko County and throughout the Midwestern United States. Too many nutrients can lead to lots of excess algae, and some algae can even produce toxins. That's one of the things we're studying here at the Lilly Center to help keep people and pets safer as they recreate out in our local lakes. They can also make excess weeds grow in our lakes, which can start to be detrimental to people's recreation in our lakes and start to choke out some of the natural functions of our lakes. We're so excited at the Lilly Center to work with several partners working alongside of us in reducing some of those excess nutrients. Groups like Soil and Water Conservation District and watershed groups and lake associations and agricultural producers themselves. We can work together to reduce these excess nutrients and make our lakes and streams healthier and cleaner as a result. If you want to learn more about some of this work that's being done, head to our website, lakes.grace.edu, and you can help us as we make our lakes and streams clean, healthy, safe, and beautiful.